Today's lesson is over sum and difference identities, and these are the 4 different variations that you'll see. You have sine identities and cosine identities. Some have a plus sign, some have a minus sign. So let's try our first example. We are going to use the sum or difference identity to find the exact value of an angle. So our first example, you have cosine of 120 plus 45. 120 plus 45 is 165. And if you look at the unit circle, this is not one of the common values that you memorize on the unit circle. So whenever you run into that and you want to know what cosine is equal to at the angle 165, you can split 165 into 2 angles that are known values on the unit circle, okay? So let's go ahead and apply the formula. The formula says I'm going to do cosine of u, which is the first value, 120 degrees, times cosine of the second value, which is 45 degrees, minus sine of the first value, 120 degrees, times sine of the second value, which is 45 degrees. That is what the identity says if you want to find the exact value of cosine using 2 different angles. So now you have to think about the unit circle. 120 degrees is right here. So this is 90 degrees and this is 120 degrees. And the coordinates at 120 degrees is -1/2 and square root of 3 over 2. The x value is cosine, the y value is sine. The next angle is 45 degrees. That's right here, 45 degrees. And the coordinates there are square root of 2 over 2 and square root of 2 over 2. Okay, so let's go ahead and solve the problem. Cosine of 120 degrees is equal to -1/2. So this value is -1/2 times cosine at 45 degrees is square root of 2 over 2 minus sine at 120 degrees is square root of 3 over 2 times sine at 45 degrees is square root of 2 over 2. Okay, now we just multiply it. So these two multiplied. A negative times a positive is negative. 2 times 2 is 4. Whenever you're multiplying fractions, you just multiply across. You multiply the numerators and the denominators. Minus the square root of 3 times the square root of 2 is the square root of 6. 2 times 2, you get 4. Now notice, my fractions have the same denominators. That means I can write it as one fraction. So the denominator will stay the same. And then you just combine the numerators. This is negative square root of 2 minus the square root of 6. And that is the value of cosine of 165 degrees. Let's try another example. So now I'm going to use this sum identity to find the exact value of this angle. Now you don't have to do this, but I'm just showing you where it comes from. If I make these denominators the same, I would multiply this by 3 and multiply this by 2, so that this becomes 9 pi over 12 plus 10 pi over 12. And then you can add these together. 9 plus 10 is 19, we have pi. So 19 pi over 12, this is not an angle that is known. This is not a common angle on the unit circle, okay? So what we're gonna do is we're splitting it into 2 angles that are on the unit circle. So let's solve it. Sine of this first angle, cosine of this angle, 5 pi over 6, plus cosine of the first value, 3 pi over 4, then sine of V, which is the second angle, 5 pi over 6. Okay, so again, you have to think about the unit circle. 3 pi over 4 is right here. and the coordinates are negative square root of 2 over 2, square root of 2 over 2. 5 pi over 6 is right here. And those coordinates are negative square root of 3 over 2 and 1/2. So sine at 3 pi over 4 is square root of 2 over 2 times cosine at 5 pi over 6, negative square root of 3 over 2, plus cosine at 3 pi over 4. Remember, the first value is cosine, the second value is sine. So I want this one right here. Negative square root of 2 over 2 times sine at 5 pi over 6 is 1/2. Now you just multiply. Square root of 2 times a negative square root of 3 will be negative square root of 6. 2 times 2, 4. Square root of negative 2 times 1 is just negative square root of 2. 2 times 2, you get 4. So your denominator, it just stays the same, and you combine the numerators. This is negative square root of 6 minus the square root of 2. Okay, so this example, they want us to find the exact value of cosine for the angle 195. So I want to know, what is cosine of 195? This is not one of the angles that we have memorized from the unit circle. So we have to split it up into values that we do know from the unit circle. So I'm going to write this as cosine of 225 degrees minus 30 degrees. And here's the formula whenever you're subtracting the two angles. I'm going to write cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Okay, so let's think about the unit circle. 225, well, this is 180 degrees. If you start here, from here to here is 180. If you go 45 degrees past 180, you'll be at 225 degrees. And that coordinate is negative square root of 2 over 2, negative square root of 2 over 2. 30 degrees is right here. And that coordinate is square root of 3 over 2 and 1/2. So cosine at 225 is negative square root of 2 over 2. And cosine at 30 degrees is square root of 3 over 2. Plus sine at 225 is negative square root of 2 over 2. And sine at 30 degrees is 1/2. Now just multiply. So this will be negative square root of 6 over 4. Plus and a minus is still negative. So this will be negative square root of 2 over 2 times 2, which is 4. And you can combine this. So you get negative square root of 6 minus square root of 2.